everybody. We are at QE-3, and we are going to be finding zeros by completing the square. So in the last lesson, we saw how to find the zeros of a quadratic function if it was in vertex or shifted form. Okay, so vertex or shifted form, we did all of these things where we had to simplify the radicals, so on and so forth. So what we're going to be doing today are finding the zeros of something that's we're going to start off with something that's in vertex form, and then we're going to move forward into factoring and completing the square, okay? So exercise 1 should be a little bit of a review for you. And the first thing we want to do is, I have this quadratic, find the zeros in simplest radical form. So if I want to find the zeros, I'm looking for when this quadratic function is equal to 0. So the first thing I'm going to do is set this equal to 0. Okay, and now all I have left to do is just solve for that x, okay? So what I would like you to do is you're going to cover anything that has to do with that x and undo what you see, okay? So I see minus 36. So to undo this and get it away from the x, I need to move it to the opposite side of the equal sign. So I'm going to use the opposite operation. So I'm going to add 36 to both sides. I did a step, so that means I go back to the beginning, write down what I didn't touch, and I got 0 plus 36 on this side. Okay, so what I want you to do is cover your x, right? And you have that 2 being multiplied by whatever is involved with this x. So to undo this multiplication, I'm going to divide by 2. Okay, so here, the 2 divided by 2 turns into a 1, and this x minus 2 all squared comes out, and I get 36 divided by 2, which is 18. Okay, still trying to get x by itself. This is a lot of multi-level stuff here. So if I cover x, right, I have 2, okay? So to undo the exponent of 2, I have to take the square root. That eliminates this, okay? I have to do it to both sides because that's what equality is. When I take the square root, it eliminates the square on this side, so out comes x minus 2, right? And then on this side, you're going to have a plus or a minus radical 18. Okay, so now let's add 2 to both sides to get x all by itself. And we have that x equals, I'm going to put the 2 first, so positive 2 plus or minus radical 18. Okay, simplest radical form. What does that mean? It means, can you write radical 18 in a easier, more simple way, okay? I think when Miss Martin was first talking about this, she made a reference to fractions where if you had 3/6, you wouldn't leave it as 3/6. You would simplify it down to 1/2, okay? Same thing here. I want to simplify this so it's the smallest numbers possible. So first I'm going to see if it's rational. Okay, I have a non-repeating, non-terminating decimal. So that means this is irrational. So I'm going to use birthday cake method. Okay, I'm going to do some side work here. I'm going to put it in a little bubble. So birthday cake, I'm going to birthday cake 18. I'm going to start with 2. Okay, so I'm going to have 18 divided by 2 is 9. Well, 2 doesn't go into 9. So remember our prime numbers that we're working with. 2, 3, 5, 7, 11, 13. That should be enough. So I can't divide 9 by 2 evenly, so 2 is not going to work. Can I divide 9 by 3 evenly? I sure can. So 9 divided by 3 is 3. And can I divide 3 evenly with any of these numbers? Of course I can. It's a 3. So that means that I'm at my birthday cake. Okay, so this was my little side work. The pair comes out as 1. So that's just a 3. And whatever doesn't have a pair stays under that radical. So what you're left with is 3 radical 2. So this is the same thing as saying 2 plus or minus 3 radical 2. Okay. So now it'll say find the zeros to the nearest 10th. Okay, so let's rewrite what we have. X equals 2 plus or minus 3 radical 2. All right, well, I have 2 zeros here. I have the 0 of x equals 2 plus 3 radical 2. Okay, and remember I also have the 0 that's x equals 2 minus 3 radical 2. Okay, so all I'm going to do is just put those right in my calculator and see what I get. So x equals 2 plus 3 radical 2. Okay, remember the radical sign here is second x squared. Okay, and I get 6 and the nearest 10th is the first decimal. So I'm going to look at the first decimal. That's the 10th spot. The next one will tell me how to round. So since this is below 5, it stays a 2. So this is 6.2. All right, the second one is 2 minus 3 second x squared 2. Okay, so I have x equals negative 2.2. Okay, so given here, when I got down to this place, basically what this means is that our zeros are not crossing at exactly these pretty points. So if I put 2x minus 2 squared minus 36, if I look at this graph, right, if I look really closely into here, it's, I froze. Okay, so I just put this little graph in here, okay? So if I look really close into this negative 2, I see that it's not exactly on the negative 2, and I see it's not exactly on the 6. So I'm not rational, okay? So I cross at some irrational numbers. That's why I have those radicals there. Alrighty, so let's do these two down here. So consider the quadratic y equals x squared minus 6x minus 16. Find the zeros of this function by factoring. Okay, so this one is actually telling us how to solve it by factoring. When you are factoring, you do the long or short diamond or X method or however you want to call it, but you make a big X on your paper. This B stands for bottom, so we're looking at negative 6 at the bottom. This C goes on top. Okay, and remember I'm looking for two numbers that multiply together to give you negative 16, but add to give you negative 6. Okay, well, let's do our factors of 16. 1 and 16, 2 and 8, okay, 3, no, 4 and 4. Okay. Alrighty, well, I think, do any of those make 6? What about 2 and 8? Let's try that. So, bigger sign, these both have opposite signs, and this one has to be negative. So negative 8 plus 2 is negative 6. Negative 8 times 2 is negative 16. Okay. Perfect. So what are my factors? My factors are x plus 2, x minus 8. Okay, so I found the factors, but what is this actually asking me to do? It's say find the zeros. Okay, well, if I'm trying to find the zeros, this product has to be equal to 0. And to find that, I use the zero product law, which says if anything is going to be a zero product, either one of them have to be equal to 0 or the other has to be equal to 0. And then I just solve. So minus 2, and x equals minus 2, and then plus 8, and x equals 8. So the zeros of your function are x equals negative 2 or x equals 8. You may see them like this with these little bracket things, negative 2, comma 8. Notice these are not parentheses. This is called set notation. Okay, it's a set of x's. All right, the next one we're going to do is find the zeros by completing the square. Okay, so again, find the zeros for completing the square. So to complete the square, if we recall, I'm going to have x squared minus 6x, leave a space, minus 16, leave a space. And if I'm finding the zeros, this thing has to be set equal to 0. Alrighty, so what are we looking for here? Remember, we're looking for what we need to add and subtract to this so I can actually factor it. So I'm going to take this number over here. So negative 6 divided by 2 is negative 3. Square it is 9. So the 9 is what I'm adding and subtracting. Alrighty. So what we did was turn this into something that is factorable by the x method. Okay, so negative 6 at the bottom, 9 at the top. We already know these two factors. It's the b over 2 term, so negative 3. Okay, so negative 3 minus 3 is negative 6. Negative 3 times negative 3 is 9. So this gives me x minus 3 squared. And then down here, I get negative 16 minus 9, which is minus 25, equals 0. Okay, so now I actually get to do the fun stuff and solve. So I'm going to cover this and undo what I see. Okay, down comes x minus 3 all squared, cancels, equals 25. Okay, cover x, and what I see is the root function. I see the exponent of 2. To undo a square, I take the square root, cancels this, I do this side. This comes out, so I get x minus 3 equals plus or minus square root of 25 is 5. Okay, and I get to add 3 to both sides to get 5 all by the x all by itself. I'm going to come up here, so I get x equals 3 plus or minus 5. Okay, that gives us two solutions. You have x equals 3 plus 5, or x equals 3 minus 5, right? You have the plus side of this and the minus side. So this one is x equals 8, and this one is x equals negative 2. Squeeze it right in there. Okay, so this is also 8 and negative 2. How nice. So just showing you different ways that you can solve it, basically. All right, we're going to do one more, just like the one we did. So let's try and factor this. So remember, this is b. Factoring means x method. Okay, so b is the bottom, c is the top, and I'm looking for two numbers that multiply to give me 2 but add to give me 3. Well, 2 is one of those prime numbers, right? The only thing that multiplies to give you 2 is 1 times 2. And will I ever add to get 6 from here? No way, Jose. Okay. So this can't be factored. Okay. No two numbers multiply to 2 and add to 6. We call this not factorable. Okay, if it is not factorable, you have to find another way to solve it. Okay, what we're going to do is complete the square. So I'm going to do x squared plus 6x, save a spot, plus 2, save a spot. I'm finding the zeros, so this better be set equal to 0. So I'm solving for x. Solve the quadratic. Okay, so to do that, I'm going to take half of this middle term. I'm going to divide it by 2, which is 3. I'm going to square it, which is 9. So that means that's what I'm going to add here and subtract here. Alrighty. Then, of course, this is something I can factor with my x method. 6 at the bottom, 9 at the top. Okay. And I already know my factors. It's this b over 2 number. Okay. I'm actually going to make this a little smaller here because it doesn't need to be that big. So what am I left with? I'm left with x plus 3 squared, and then 2 minus 9 is minus 7. Okay. So now I'm just going to go right on my way, and I'm going to solve this. So the first thing I'm going to do is add 7. Okay, and I get x plus 3 all squared equals 7. I'm going to take the square root. That eliminates the square. Okay, and I get x plus 3 equals plus or minus radical 7. And I'm going to subtract 3. And this gives me x equals minus 3 plus or minus radical 7. Okay. What kind of numbers are the solutions? So if I put this into my calculator, negative 3 plus radical 7, negative 3 minus radical 7, what are these numbers? Okay, these are irrational. When are you going to get irrational numbers? When you can't factor it. Okay, so when you can't factor it, that's when those irrational answers come. Okay, alrighty. So example number 4 is the last one we're going to do today, and probably one of the most important things. It's very important that you can go back and forth between these two things. So the quadratic function pictured has a leading coefficient equal to 1. Answer the following questions based on your work. Write the equation in vertex form. Oh, okay. Do you remember vertex form? Huh? All right. So vertex form is when you have that H and K where you put that turning point into there. Okay. So it's y equals a x minus h squared plus k. Okay, this is your turning point or your vertex. And remember, we put in the opposite of what we see. So let's identify the vertex, aka the turning point, and I get negative 1 for my x, and down 1, 2, 3, 4, and negative 4 for my y. Okay, and remember when we pulled the vertex from the equation, we said opposite x, same y. And we pulled it from the x here, and the y was here. Okay. Oopsies, squared. Right? So if I want to put it back into the equation, I'm basically doing the opposite. So the vertex is negative 1. So if I got a vertex of negative 1, what should have been inside my parentheses? Well, it should be a positive 1. Okay? Because I would take the opposite value of that x. The opposite of 1 is negative 1. And then I keep the same y. Okay, so here is the equation of this in vertex form. I guess we could throw it right in there just to make sure that it looks similar. So I get x plus 1 all squared minus 4. I'm going to look at this graph. Oh yeah, bingo. Okay, looks identical. Second one says write the equation of this quadratic in factored form, okay? Factored form is when we had those binomials being multiplied together, okay? So, and where did we get this? Those were our zeros, okay? These are the zeros of the function. And remember, those are also the opposite signs. So I have a 0 here at -1, -2, -3. So x equals -3. And I have a 0 here at x equals 1. So if I wanted to solve this, this is when we use this table, we put the opposite in. So this would be x plus 3, x minus 1. Because if I solved this, this would be set equal to 0, and I would have x plus 3 equals 0, and x minus 1 equals 0, and I would solve for x. And the last thing we're going to do is, this says, how could you establish that these were equivalent functions? The only way I could establish if these two are equivalent functions is if I put them both in standard form. And what is standard form again? Is ax squared plus bx plus c. Okay, so that's what we're going to do. The first thing I want to do is write this one in standard form. So y equals x plus 1 squared minus 4. This is the same thing as saying x plus 1 times x plus 1 minus 4. Okay, I'm multiplying here, so that means I'm going to do that little box method thing. I have one operation here and one here. So I get x plus 1 times x plus 1. I do that pun and square. X times x is x squared. 1 times x is 1x. 1 times x is 1x. And 1 times 1 is 1. We do the peanut. And inside the peanut, we add. Okay, so what's left over is x squared. 1x plus 1x is 2x plus 1 left over. And then don't forget that minus 4. Simplify this. X squared plus 2x. 1 minus 4 is minus 3. Okay, so that's my equation here. The second one I want to prove is this one. So I would get y equals x plus 3 times x plus minus 1. Uh-oh, I don't have an eraser. You see, it's empty. Okay, same thing here. These two are binomials being multiplied together, so I'm going to do this box method. One operation this way, one this way. So I get x plus 3, x minus 1, and then I pun and square. So x times x is x squared. Negative 1 times x is negative 1x. 3 times x is 3x. And 3 times negative 1 is negative 3. I peanut here. Inside the peanut, it tells me to add, of course. So I get x squared, 3 x's, I take away 1, is plus 2x, and then minus 3. Okay, equivalent. Awesome. That's all. I hope you have a good day. Please let me or Miss Martin know, obviously, if you have any questions.